What's up, Raiders? Just want to give a quick overview of the different type of angle pairs that we'll be working with. And the first thing I want to say is one thing to kind of keep in the back of your head as we go beyond identifying angle pairs and where they are. The next step is what's true about their measurements. And in the circumstances that we're going to be dealing with, we're going to see that there's two different possibilities. So while there's several different angle pairs we're going to identify, there's only two end results that can be true about them. Either their angle measurements are going to be equal to each other, so we could write that as something like the measure of angle 1 equals the measure of angle 2. And then a slightly different way of communicating this. If angle measurements are identical, then that means the angles themselves would be congruent to each other. So we could also just say angle 1 is congruent to angle 2. Just a slightly different way of communicating the same information. So that's one possibility with these angle pairs, is that their measurements are going to be equal to each other, or the angle measurements are going to be supplementary. They would add up to 180 degrees. So we could say that the measure of angle 1 plus the measure of angle 2 equals 180 degrees. So just kind of keep that in the back of your head as we identify the different angle pairs, because that's the next step when we analyze different diagrams. If we know these two possible things are going to be what's true about the angle pair measurements. So first things first, vertical angles. So anytime you have two line segments or rays that intersect and form an X, vertical angles are going to be the angles that are across from each other. So they share a vertex, but that's it. So that would be like angle A and angle B. And what turns out to be true, no matter what, is that these angles would be congruent to each other. So we could put these tick marks here. So we could say that the measure of angle A equals the measure of angle B. Or again, we could say that angle A is congruent to angle B. So those are vertical angles, angles that are across from each other anytime you have an intersection of two line segments or rays. Just like we could also say angles C and D are congruent to each other because they're vertical angles. So angle C would be congruent to angle D. Okay, now, linear pairs. Linear pair of angles, we can identify them in the same type of setup. If we have an intersection of two line segments or rays, so instead of talking about angles that are across from each other that share a vertex but nothing else, now we're going to talk about two adjacent angles right next to each other. So in this case here, if we have angle A and angle B here, notice that they share a vertex, but now they also share a side here, and collectively when you put them together, they make a straight line or segment. And if you think about a straight line or segment, first things first, if you think about a 90-degree angle, like the capital L, well, if you put a backwards one back to back with it, 90 and 90 degrees adds up to 180, so collectively, anytime you go all the way across a straight line or segment, you've got 180 degrees. So in this case here, with a linear pair of angles, where they share a vertex, here's the vertex for angle A, and at the same time, that's the vertex for angle B, and they share a side, and collectively, when you put them together, they make a straight line or segment, which has to be 180 degrees. That tells you that linear pairs are supplementary. So we could say that the measure of angle A plus the measure of angle B equals 180 degrees. So for example, if the measure of angle A is 130 degrees, then we can figure out the measure of angle B with solving this simple equation here. If the two angles collectively have to add up to 180 degrees, and we know that one of them is 130 degrees, well, then the unknown angle has to be, in this case, 50 degrees. Okay, now getting a little more complicated, corresponding angles. So let's say we have two segments here that do not intersect. And now we have a third segment that goes through both of them. Now just a little vocab. If you have a segment that intersects two or more line segments or rays, we call that a transversal. And now if we take a look at what we've got here, we have now with these three segments, we have an intersection up here, just like we did earlier with linear pairs and vertical angles. And then we also have a second one down here. So you could kind of look at this as up top here, you have 1, 2, 3, 4 individual angles, and then down below that in the next intersection, you have 4 more individual angles. So we have vertical angles and linear pairs there, like here's vertical angles, here's another pair of vertical angles, these two are a linear pair, these two are a linear pair. So we see kind of embedded in here the vertical angles and linear pairs we've already talked about. Now corresponding angles, that would be two angles that are attached to the same transversal and they're in the same matching spot. So if you look at this intersection up here of these four individual angles, you can kind of think of this as being the top left spot out of this intersection, top right, bottom left. Well, if we go down here, that pattern repeats. Not for the overall diagram, but just focusing on this intersection, this is the top left spot of the intersection, top right, bottom left. So if we have angle 1 right here, that's in the top right spot out of that intersection. Well, find the same matching or corresponding spot down here, and that's right there, angle 2. And what turns out to be true is if these two intersected segments are parallel to each other, then basically you have kind of a repeating pattern of how these angles interact with each other. So then what you'd have is that these angles would be congruent. So we could say that the measure of angle 1 equals the measure of angle 2. Or again, angle 1 is congruent to angle 2 because the angles themselves would be identical. So corresponding angles, if the intersected segments are parallel, corresponding angles would be congruent. So another pair of corresponding angles on here would be if this is angle C, well, if you look at this grouping up top here out of these four individual angles, this is the bottom left spot out of this grouping. So find that matching or corresponding spot down here. Here's the bottom left spot here, angle D. So the measure of angle C equals the measure of angle D. Okay, moving on, we're going to use the same setup here with two line segments or rays intersected by a transversal. Alternate interior angles. So if we have a setup like this, now I'm purposely going to draw my two intersected segments that visually do not look parallel. So now alternate interior angles. Notice there's two parts of the name, alternate interior. So there's basically two conditions you have to satisfy for an angle pair to be considered alternate interior angles. So if I have angle A here and angle B, notice where they are relative to the transversal. A is to the left of it, B is to the right of it. So they're on opposite or alternate sides of the transversal. That's the alternate part of alternate interior. And now, well, what are they on the interior of? Well, look at the two intersected segments. Notice that angles A and B are inside those intersected segments. So collectively, these are alternate interior angles. They're on the alternate sides of the transversal, and at the same time, they're on the interior of the two segments the transversal intersects. Now, if these two intersected segments were parallel, then these angles would be congruent to each other. But in this diagram, since visually these are not parallel, we cannot say that they're congruent angles, but they are still alternate interior angles. Okay, same side interior angles. Following the logic of what we just talked about with alternate interior angles, now we have the same setup here, and let's say that these two intersected segments are parallel to each other. So same side interior angles would be something like angle A and angle B. If this is the transversal, notice that A and B, they're both to the left of that, so they're on the same side of the transversal. And then the next condition, notice that the two intersected segments, the angles that we're talking about, are on the inside or interior of them. So these two angles satisfy the conditions of same side interior angles. And because the intersected segments are parallel, then the mathematical relationship between these angles holds true, that they're not congruent to each other, because if you look, this one's obtuse, it's more than 90, and visually this one's acute, it's less than 90, so they can't be congruent to each other. They're going to be supplementary. So we could say that the measure of angle A plus the measure of angle B equals 180 degrees. So if angle B was 60 degrees, we could then use that information to figure out, because we now know what this is, it's 60 degrees. So the measure of angle A plus 60 degrees equals 180 degrees. Subtract 60 from both sides. So the measure of angle A equals 120 degrees. Okay, last angle pair we're going to talk about, alternate exterior. So again, we'll stick with the same diagram of two line segments or rays that are intersected by a transversal. And let's say that these two intersected segments are parallel to each other. So now, kind of building off of what we've done up above, if we have angle 1 and angle 2, notice they're on opposite or alternate sides of the transversal. Angle 1's to the left, angle 2's to the right. And now look at the intersected segments. Notice that angles 1 and 2 are on the outside or exterior of them. And what ends up being true is that these angles are going to be congruent to each other if the intersected segments are parallel. So the measure of angle 1 equals the measure of angle 2, or again, you can say that angle 1 is congruent to angle 2. So that's just kind of a quick overview of how you can identify the different angle pairs and what's mathematically true about them under certain conditions. So like always, if you have any questions, you can contact me on the Remind app, and on our Google Classroom page, you'll find a link that I've given to GeoGebra and some interactive applets you can work with to help you identify these angle pairs. Take care, Raider Nation.